Okay, next lesson. In this lesson, we're going to be working with the quadratic formula and how we can use it to help us sketch some tricky graphs. So, firstly, what is the quadratic formula? Well, it's this whole big equation over here, this whole thing. Okay, and basically, in our case, we're going to use it to find our x-intercepts. Okay, we can also use it to find other solutions to any other quadratics we want, but in our case, we're going to be using it to find x-intercepts. Okay, so let's try do this question let's try finding x-intercepts of this question. So, how do I find x-intercepts? The rule for x-intercept, we did this last lesson, is to make y value equal to 0. So if y is equal to 0, 0 is equal to 3x squared plus 4x minus 2. Right? At this stage, I would try and factorize. Now, I would try and take 3 out as a common factor, but I can't do that because it's not factor of 4 and negative 2, so I can't take it out. So if I can't take it out, I'll do the other way of factorizing. Remember, you multiply the first and the last number, which is 3 times negative 2 is negative 6. And factors of negative 6 that add to positive 4. So let's see. 1 and 6, neither of those add to 4. 2 and 3, that doesn't add to 4. Okay, so none of these factors add to 4. And these are all the factors of negative 6. So if you can't do any of that, if you can't do normal factorizing, your kind of last backup plan is the quadratic formula, which is this whole thing here. Okay, so there's a backup plan if you can't factorize normally. Right, so first we start by identifying a, b, and c. A is the coefficient of x squared, which is in this case is 3. So this is our a value. B is the coefficient of x, which in this case is 4. This is b. Okay, and c is the just the whole number. It's the number by itself, which in this case negative 2. So it's c. So you have a, b, and c, and all we have to do is plug it into this equation here. So we have x is equal to negative b, so negative 4 because of b is 4, plus or minus square root of b squared, which is 4 squared minus 4 times a is 3, times c is negative 2. So make sure you put the negative there, it's pretty important. Divided by 2 times a, so 2 times 3. And that's it, we subbed all the numbers in, and let's now simplify this to get the x-intercepts. So x equals negative 4 plus or minus square root 4 squared is 16. 4 times 3 is 12. 3 times negative 2 is negative 24. But there's already, you can see there's 2 minuses here. So negative 4 times negative 2. So both 2 minuses multiplying will make a plus. So this would be a plus 24, like so. Divided by 6. Okay, let's keep going, almost done. Negative 4 plus or minus square root of 40 over 6. Now we can simplify this third. We talked about simplifying thirds before. So you can say x is equal to negative 4 plus or minus root 4 times 10, right? Because 4 times 10 is 40. And you can take the 4 out by square rooting it, so you can write as 2 root 10, like so. Divided by 6. Now from the top, what you can do is take out the common factor. So pretty much because it's 2 times 10 and this is 4, they have a common factor of 2 on the top. So you can take the 2 out. It's going to be negative 2 plus or minus root 10. Pretty much 1 times root 10, which is root 10. Like so. So I just took out the common factor from the top. Yeah, don't get confused because it's a plus or minus. Just think about it how you would do if it was just plus. Okay, if it was just plus, so it was negative 4 plus 2 root 10. How would you take out the common factor? You would take 2 out as a common factor. It will just be negative 2 plus root 10, like so. So don't get confused with the plus or minus. It's the same thing. Okay, so divided by 6. Now, why did I do that? What's the whole point? Well, because these are multiplying, I can cancel out. 2 goes into 2 once, 2 goes into 6 3 times. So you're left with negative 2 plus or minus root 10 over 3. So then what are your two x-intercepts? We dealt with plus or minus before. All we have to do is split it up. Your first x-intercept is negative 2 minus root 10 over 3. And your second x-intercept is negative 2 plus root 10 over 3. So you take the negative version first and then this positive version. That's it, okay? So these are our x-intercepts. And remember, I'm stressing this point, you only use quadratic formula if you can't factorize normally. It's kind of a last resort thing, okay? Because you can see it takes a bit of work to do. It's much harder than factorizing. So if you can factorize, just do that. Okay, we'll do one more example really quickly. So let's say I'm trying to find, again, x-intercepts of this graph. So I have this is a value, so I have to, obviously, well, I'm just going to assume we can't factorize this. So firstly, for x-intercepts, you make y0, y equals 0, 0 is equal to 2x squared minus 5x plus 6. So I'm just going to say, all right, I can't factorize it, all right? So because 2 times 6 is 12, no factors of 12 add to negative 5. Okay, so we got that done, so we'll just factorize it normally. We'll use quadratic formula to factorize. So again, a is 2, b is negative 5, this is b, and c is 6, a, b, c. And we can now sub it into our formula, quadratic formula. So we have x is equal to negative b, so negative of negative 5 will actually make a positive 5, plus or minus square root of b squared, so negative 5 squared, minus 4 times a is 2 times c is 6, like so. All that divided by 2a, so 2 times 2. So you have x is equal to 5 plus or minus square root of 5 squared is 25, and 4 times 2 times 6 is minus 8, so 28 times 6 times 8 is 48 over 4. Okay, let's keep going. X equals 5 plus or minus square. You'll notice something weird has happened here. So it's going to be negative 23. Now this should be setting off an alarm in your head, right? Because what we have here is a square root inside, or sorry, a negative number inside of a square root. Now what does that mean? We can't have a negative number inside a square root. So this means that this is undefined. Undefined. So what does undefined mean? Well, there are no x-intercepts. So therefore, no x-intercepts for this graph. Okay, so a quadratic formula will tell us that as well. So if you do the quadratic formula and you get a negative inside the square root, then no x-intercepts. That's it. Okay, let's keep going. Have a go yourself and find the x-intercepts of both these graphs. Okay, so this is the answer to part A. Part A is fairly simple. We've done these questions already, so I hope you got that. But part B is a little different. You'll notice there's a K in there. Right, so part B is a little bit different. So we'll do that together. So again, we have to use quadratic formula if there's a variable in there, because you can't factorize normally. It's a bit hard. So we use quadratic formula to do it. So firstly, we need a, b, and c values, right? So firstly, we'll talk about what is a. Well, a is the coefficient of x squared. The coefficient of x squared in this case is just 1, because there's no number there, so it's just going to be 1. So a is 1. B is a little weird, right? It's a coefficient. B is the coefficient of x, which in this case is this whole thing over here. In this case is 3k. That's b. And c is actually the whole number, so it's negative 5. Okay. From here, we just need to put it into our quadratic formula. So let's do it. So you have x equals negative b, so negative 3k, plus or minus square root of b squared. So b squared is 3k whole thing squared, minus 4 times a, which is 1, times c, which is negative 5. Like so. All that divided by 2 times a, so 2 times 1. And then all we need to do is simplify. Negative 3k plus or minus square root of 3k whole thing squared is going to be, you're going to square both things, so 9k squared. And then negative 4 times negative 5 is going to be positive 20. So 9k squared plus 20 over 2. Again, that's it. You don't need to simplify it too much more than that. Okay, that's about it. So I hope you got that as the answer. It's a little different. But let's talk about why we need the quadratic formula to do these questions. So let's say I'm trying to sketch this graph. Okay, so I'm trying to sketch this graph. Obviously, it's in general form. So it's in the third form we talked about. So if it's in the third form, we do intercepts first, x-intercepts. So to do the intercept first, you make y0, x squared plus 4x minus 2. Now you try to find the x-intercepts normally by factorizing. So factors of negative 2 that add to 4, that add to positive 4, but you realize there aren't any. There are no factors. So if there are no factors, how do you find x-intercepts? Is what we've been doing this whole lesson, is just to use the quadratic formula. So here's the quadratic formula. So a, what is a? A is 1, because there's no number in front of x squared. B is 4, and c equals negative 2. So here's quadratic formula. X equals negative b, so negative 4 plus or minus square root of b squared. So b squared is just 4 squared minus 4 times a, which is 1, times c, which is negative 2. All that divided by 2 times a, which is 1. Because it's quadratic formula, we've been doing this. So x equals -4 plus or minus 4 squared is 16, and -4 times -2 is +8. So 16 plus 8 over 2. Okay, 16 plus 8 is the only simplification we can do in this step, is going to be 24 over 2. And then we just need to simplify this as much as possible. So root 24 I can write as, so how can you split it up? How can you simplify the third? It's going to be the same as square root of 4 times 6. So root 4, 4 I can take out by square rooting 4. So square root of 4 is 2. So you're going to be left with 2 root 6. So root 24 simplified over 2. Now we're going to do the same thing what we did before previously, is factorize the top. So I'm going to factorize 2 out. 2, -2 plus or minus square root 6, all that divided by 2, and then I can cancel out the 2's. So all I'm left with is -2 plus or minus square root 6. Okay, so what are my two x-intercepts? So if it's a plus minus, we need to split it up. So to split it up, it's going to be the first x-intercept is -2 minus root 6. Second x-intercept is -2 plus root 6, like so. That's it. Okay, so we've got our two x-intercepts. So the easiest way you can do this is first find -2. So -2 is roughly here. Okay, so you can go plus root 6 this way and minus root 6 this way. Now you might be asking, okay, is the x-intercept here or is it after the y-axis? So in other words, does your parabola, does it do something like this, right, where the second x-intercept is there, or does it do something like this, with the second x-intercept is positive? And it's a pretty important difference to make, to find when you're sketching. So in order to answer that, what we're going to do is find the y-intercept. Well, what's the y-intercept? You make x 0. If you make x 0, y-intercept is -2. So y-intercept is -2. It's going to be roughly over here. 0, -2. Right? So now you know, right? Because your graph has to do something like this. It has to go through the y-intercept, like that. Right? So that means your second x-intercept, it's going to be on the positive side. Because it has to go through that y-intercept. In other words, let's just pretend for a second that instead we got a y-intercept to be 0 and 3, for example. Then your graph would have to do something like this. Right? It has to go to the positive side. That means your second x-intercept, this one, is going to be negative. It's going to be negative because it's on the left side. Right? So there's a difference between the two. If that didn't make sense, pretty much the gist of it is just to find the y-intercept and then sketch your graph so that it makes sense based on that. So y-intercept here, that means because your graph will do something like this, your next x-intercept will be on the positive side, and the other one's going to be on the negative side. So this is going to be -2 minus root 6, because that's a smaller number, and this one over here is -2 plus root 6. That's the bigger number, so it's on the right side. Okay. Next, when you're doing this, guys, we need to find the turning point. That's the last step in this question. So in order to find the turning point, I told you one way, which was to use the x-intercepts, right? But there's actually another way you can use, another method to find the x-coordinate of the turning point, which is pretty much -b over 2a, right? What is this b and a? Well, it's what we found already. This is b and this is a, right? That's another, so no, of course we can do x1 plus x2 divided by 2 like we did last lesson, but you can see x1 and x2, our x-intercepts are pretty weird. They got like surds in them, right? We don't like surds. Bit annoying to work with. So instead, what I'm giving you is an alternate method, which is -b on 2a. Right. So -b on 2a is really simple. So what is our b? B is 4, so -4 over 2 times a is 1. So x-coordinate of the turning point is -2, if you simplify that. So it's pretty much over here somewhere, -2. We already have it. So to find the y-coordinate, you just need to sub it into here. So we'll sub it in quickly. So to find the y-coordinate of the turning point, it's going to be -2 squared, so I'm just subbing it in, plus 4 times -2 minus 2. Okay, so let's do this. -2 squared is 4, 4 times -2 is -8, minus 2, -4 minus 2 is -6. Okay, so our turning point is -2 and -6. So we have everything we need to sketch, so let's do it. So over here, and sketch out the parabola, like so. Boom. Okay, make sure it goes through all your coordinates. That's it. Okay, so again, same steps, but we just use a different method at each step. So we use the quadratic formula to find the x-intercept, and we use the new method for finding x-coordinate of the turning point. Okay, hope you understood. Let's keep going. So have a go yourself, and we'll do this together, both of these. So have a go and see if you can sketch these graphs out. So we'll do the first one. X squared minus 2x minus 10. So of course, x-intercepts first. To find x-intercepts, you make y 0. X squared minus 2x minus 10. Then use quadratic formula, because if you try to factorize this, you won't be able to. So use quadratic formula. So what is a, b, and c? A is 1, b is negative 2, and c is negative 10. So use quadratic formula. X equals negative b, so negative of negative 2 is 2, plus or minus square root of b squared, so negative 2 squared, minus 4 times a is 1 times c is negative 10. I know it's a big formula, but you'll get used to it as you do it more and more often. Over 2 times a, so 2 times 1. So x equals 2 plus minus square root 4. Negative 4 times negative 10 is 40, so plus 40. And over 2. So, and then it's going to be x equals 2 plus minus square root of 44 over 2. Square root 44 will simplify to 2 plus minus 2 root 11 over 2. And if you factorize the top, it's going to be, take the 2 out, 1 plus or minus root 11 over 2, and then you can cancel out the 2's. So your two x-intercepts are going to be 1 minus root 11, it's your first one, and the second one is 1 plus root 11. Okay, so pretty much find 1. Okay, so we don't know if the x-intercept is going to be here or here. So in order to figure it out, so it's your x-intercept is definitely going to be on the right side somewhere here, and we don't know it's going to be here or here. So that's what I'm trying to say. So then you find the y-intercept, which is negative 10 in this question. It's going to be somewhere down here, and you can, if you visualize the shape, your second x-intercept is going to be something on the left. So it's going to be over there. Okay, so let's label everything. 0, negative 10, 1 plus root 11, because the bigger number is the plus. 1 minus root 11 is on the left side, it's a smaller number. Okay, and then to find the x-coordinate of the turning point, what we're going to do is use this new method we learned. X-coordinate of turning point is going to be negative b over 2a. So which is negative of negative 2 over 2 times 1, which is 1 if you work all that out. So it's 1, and the y-coordinate, I'll do it quickly, is negative 11. So if you sub it in 1, negative 11. So this should have been your parabola. Hope you got that. Okay, last question for the lesson. This is a little bit more complicated, so let's do it quickly. So to find the x-intercept, same thing. Y equals 0, so obviously try factorize it normally. If you can't factorize it normally, then use quadratic formula. So same thing, a equals negative 4, b equals 2, c equals 5. Okay, once you have that, we can start using quadratic formula. X equals negative b, negative 2, plus minus, I'll do this one quickly. B squared is 4, minus 4 times a is negative 4 times c is 5. All that over 2 times a, so 2 times negative 4. So x equals negative 2 plus minus square root. Okay, so this one's a little tricky. Negative 4 times negative 4 is positive 16. Positive 16 times 5 is positive 80. Yes, positive 80. So 4 plus 80 is what we have there. Okay, 4 plus 80 over negative 8. 4 plus 80 is just 84. So let's write it here, 84. Now we can simplify that by taking out common factor, which is 4. So we can split up root 84 into 4 times 21, like so. And so I'm just simplifying the third over negative 8. Negative 8. Now you can take out the 4 by square rooting it. So 2, so it's pretty much 2 root 21, like so. 2 root 21. So again, we're going to do the same thing and simplify the top by taking a common factor of 2, negative 1 plus or minus square root 21 over negative 8. And then you can cancel out. 2 goes into 2 ones, 2 goes into negative 8, negative 4 times. So all you're left with is negative 1 plus or minus root 21 over negative 4. That's it. Okay, I say that's it, but it's a pretty big process, I know. right? This whole thing takes a while. Yes. So I hope you didn't zone out when I was saying all those things. So just try, do it yourself one more time if you didn't get it. Right, it's a pretty big process, but you have to get used to it, unfortunately. So what are x-intercepts? It's going to be -1 minus root 21 on -4. And x equals -1 plus root 21 on -4. Okay, so let's do it. Let's see. We don't know where to put it. So let's first get the y-intercept. The y-intercept is going to be 5, 0, and 5 up here. And while we're here, let's also get the x-intercept, because this is a pretty complicated number. We don't know where it's going to be roughly. So instead, let's just find the turning point first. So if you ever don't, that's what I'm saying, if you ever don't know where to put these numbers on your graph, because you don't know the actual values, find the turning point and it'll be pretty clear. So let's find the turning point. Remember I said x-coordinate of the turning point equals -b over 2a, which is going to be -2 over 2 times -4, which is going to be -2 over -8, which is a quarter. So the x-coordinate of the turning point will be a quarter, and it'll be roughly over here. You can sub it in and find the y-coordinate yourself. So if it's over here, so it's a quarter and whatever the y-coordinate is, right? So sub it in and find the y-coordinate. You can, if you visualize the shape, it'll look something like this. So that's the turning point. And oops, not very symmetrical. Okay, remember guys, you have to be pretty symmetrical when you're drawing these. So if you visualize the shape, it'll look something like this. So once you have your shape, then you can just plot in your x-intercepts. So that strategy is for if you don't know where to put your x-intercepts. So let's do it. The one on the left is -1 minus root 21 over -4 and 0. And the other one, -1 plus root 21 over -4 and 0. That's it. Okay, we sketched out the graph. So I hope you understood. This was a bit of a long lesson because there's a lot of maths to do, a whole bunch of working out, but it's a quadratic formula. Okay, I hope you are familiar with it. Make sure you get a bunch of practice. Okay, so that's it for this lesson. I'll see you soon.